looking forward to meeting you afterwards. My name is Andrew Stiefel. I'm head of product marketing at Endor Labs. What that means is I get to spend a lot of my time talking with customers, learning about the product, and talking with interesting people in the industry. So just a little bit about Endor Labs. We're an application security company founded in 2023. Do all the standard things we kind of expect, SAST, SCA, secrets, container, all that kind of stuff. But also been more recently digging into the security risks around vibe coding. And so the plan tonight is to kind of walk through a case study and then do a little bit of vibe coding live and kind of see what happens today with Cursor and ChatGPT. Just a little bit more about me. I've been at Endor Labs for about a year. Previously worked in developer security at 1Password and Nginx. But more relevant for tonight's conversation, I was vibe coding before it was cool. I am completely self-taught, which meant back, 10, oh God, I think it was 15 years ago. I actually realized recently, 15 years ago, that meant tweaking one line of code at a time, seeing what breaks, and then iterating to find out. So needless to say, I've found all sorts of interesting ways to break code over the years. And vibe coding is a lot of breaking code a lot of the times. But before we get, Before we get into the presentation, I think the reason we're all here tonight is to win a raffle. So scan the QR code, and you can take home this Star Wars Ewok. Obviously, we're huge fans of Star Wars at Endor Labs. You don't have to use a work email. You can use a personal email. We won't spam you, I promise. But you could win a cool prize tonight. I will wait 1 second while everybody scans. Sorry, what? Is it safe? The QR code? The QR code is safe. Yes, sorry. Forgot it. As safe as it can be. You have to trust me. Do with that as you will. Yeah. We're going to skip the trust. We're going to trust. You'll do the verification later in the process. All right. Everybody got it? Why come to an OWASP meetup if you don't get a prize, right? Okay. I think we all know everybody's using AI today. It's not going to spend too long on this. What I did notice, this came out recently from Stack Overflow and caught my eye. I think last year it was like 70% of all developers were experimenting with AI at all. Now it's over 80% are actually using these AI tools at work, which I thought that's the biggest change that stood out to me. Everybody claims different amounts of code that are used at work. But the other stat we're going to be spending a lot of time tonight talking about is this last one, which came from an academic study that was released, I want to say around March. It basically looked at the rates of failure in AI-generated code. And that top line number actually hides two interesting statistics underneath of it. AI code breaks in two interesting ways. The first is maybe less interesting. It's all the traditional problems you would expect. So about 30% of it is like security weaknesses that you would find with SAST. The other 30%, though, is design flaws. And so these are things that sneak into code that impact your overall functionality of the application, but also your security posture. And that's what we're going to be spending today talking about. Before I go on, though, I'm just kind of curious just to get a feel for the room. How many people have actually used Cursor, GitHub Copilot, or one of these tools themselves? OK, so we have some vibe coders in the room. How many of you have organizations where maybe you're not using it, but your developers are using these tools already? OK, smaller group. And how many people are either themselves or at their work building agents or doing anything with models? OK, so a mix. Great. So as we go, feel free to jump in with questions. Happy to dig in, and we'll also leave lots of time near the end for a discussion. All right, so we kind of talked about how AI can break. I think we've all seen this, right? Very common. This poor guy, I think he's on every single vibe coding presentation. Right? But things happen, things break, and we want to obviously make sure things don't break. And that's what we'll be talking about tonight. Just to kind of put a hypothetical here, right? This is not going to spend too long here. I want to get into the actual case study, but the reason AI can make mistakes is, again, those design flaws, right? So we don't have authentication in place, or authentication has changed. This is what creates those gaps in our applications, which then leave them open to exploit. I think we all kind of know this as security professionals. What I want to talk about as we get into this, though, I want to actually use this definition to frame the rest of the conversation. So there's the difference between programming, which is the act of generating and writing the code, and software engineering, which is managing the long-term evolution of that application in a way that is valuable, right? Code is a form of debt. Doesn't matter if it's good code or bad code, it's a form of debt that you have to maintain. The challenge with AI is that it accelerates the amount of debt we can build in the organization. So how do we, as either on the engineering side, as an engineer, secure and reduce some of the cost of managing this debt, but also on the security side, how do we work with engineers to reduce that debt? And now for the case study. So we have been vibe coding lots of apps at Ender Labs to kind of see what happens when we do this. And what we're going to talk about today was actually trying to vibe code a application to track a board game collection. So you can imagine this is a really over-engineered Excel spreadsheet, but interesting to kind of see how it came together. We'll talk a lot more about all the things that happened, but you kind of see the high-level summary here, right? So over 1,200 dependencies at the beginning. We're using JavaScript. Probably not going to shock anybody that there's a ton of dependencies in there. Some critical CVEs and that open source ecosystem behind it. Lots of issues with first-party code. That took us 10 minutes. So this is a ton of security debt in about 10 minutes of work. What we'll talk about more, though, and I think is interesting, though, is when we tried to reduce the security debt by reducing the number of dependencies. Cursor and the LLM we're using in this case, ChatGPT, increased it to 1,600. So even though we specifically told it to reduce some of this dependencies, it actually increased it. And so kind of speaks to the unintuitive way some of this stuff, the technology can work. So some high-level principles, then we'll get into the security lessons. I think a lot of times we think that the non-deterministic nature of these LLM models is a drawback, but it's actually a positive. It's the way they're designed, but it has some implications for how we interact with them, right? So first of all, different prompts, or even the same prompt, can result in different results. That's, again, by design. We want to get some of those creative outputs that we can actually get value out of the tool. That means, though, that the model you're using is also a dependency, right? So if the same model will give me different results, changing the model will give me even more different results. And so we have to start thinking about the model as a dependency, not just what we're actually building in the application. And finally, again, I would just want to emphasize this a lot, is that the freedom there, we break out of the if-then type of coding. We actually get to have different results. That's really exciting, but it also means that these applications can break in different ways. So just to kind of illustrate, this is 2 examples here of showing like how an LLM can become that dependency. And in this case, you see the prompts we were using, and we used 2 different models. And in this case, we got with ChatGPT 4.1, had 2 backend dependencies. With Claude, we had much more. Looking at just the code here alone without actually testing the application, it's hard to say which one is better. Maybe more dependencies is better in the case of Claude. We don't actually know. But the point is we ended up with 2 very different looking applications. And I will also say, having used Claude in the past, sometimes it'll give me something pretty much what I asked for. Other times it decides to take initiative. The same prompt, I just asked it to build a front end and back end. On multiple occasions, it decided to add a Docker file because clearly I needed that too for deployment. So that kind of gets to the next point, is expect the unexpected, right? It's not going to always do exactly what you think it's going to do, even when you ask it for it. And the biggest thing we've kind of seen is small feature changes can have big impact. There's actually a study that just came out this past week. Talked with Yath through it. I can send you the link, but actually found that as you iterate with these tools, they increase security debt, right? So every time I do an iteration, it increases the number of vulnerabilities. So it started with around 40 to 70 the application, and by the end you had over 100 vulnerabilities in the application as we iterated to add these additional features. Again, that's the next point, that vulnerability multiplication. And again, we've been talking about this a lot, but also those risks beyond what we would typically find with SaaS or SCA, right? Those known CWEs or CVEs. And this is an illustration of that, right? You could call this a CWE, right? But actually what happened here is when we were working with the LMM, the ask was to actually simplify a login flow. And what happened here is it actually removed a parameter and changed the overall security. And these are sort of the counterintuitive things where it may or may not get caught in SAST, right? Because it's not actually a direct vulnerability, but it is a change in our security posture. So other examples might be that we've seen happen, swapping cryptography libraries, right? That's a pretty big change. May or may not show up in a SAST scan because it's not strictly wrong, but it may not be what your organization wants to see in terms of security posture. all sorts of things like that. And the other reason to kind of call this out is like, again, professional developers aren't, for the most part, vibe coding entire applications. They tend to be actually using tab accepts. And our developers have kind of seen that's where these types of problems come in, is actually the tab accept, where it looks pretty close, but it changes just a little bit. One example might be changing a login from 30 minutes to 30 days. On a quick glance, it can look the same, but you've actually created a much longer lived session, for example, in the browser. Okay, so what can we do in an organization to help with this? And we're going to start from, I'm going to say, is the most naive and easiest to something that's to be more involved. A lot of this starts with the prompts, and I think, a lot of organizations today, we do write spec docs. We have PRDs and all of those kind of things written out, but the prompt in many ways is now the most important design document itself, and it's important to build in security there. I'll show you an example here in a second, but even just saying write secure code drastically improves the quality of the code that is written. So that's kind of that next step, priming for security. But again, that's pretty naive. You're not going to get a ton of great results. However, there are techniques that you can use to get better results from the LMM. That's where you can actually start using reasoning. And so I'll show you an example here. This is the basic prompt, right? So we had, write in a Python script that takes the host name, inputs it, ping 4 times. Very basic example. Just adding, I want secure Python code. Suddenly, we have something that's much more mature. Again, I don't know if it's right in the context of this application, but we've done some simple validation. We're doing some steps to present shell injection. And so again, there's been some changes made. Again, this is the really simple process. But again, in that academic paper I mentioned earlier, they actually found that a technique called RCI, responsive. I'll look it up later. Sorry, I'm blanking right now. Anyway, the way it works is you kind of start with this prompt over here, but then you actually ask a different LMM to evaluate it, identify the security flaws, and then go back and ask for the changes. And this kind of process decreased security vulnerabilities by about 74%, right? So easy way to start secure up front. So these are some categories of examples you can look at. The one I was just talking about is that reasoning-based. Priming is that example of starting secure. You can also do decomposition-based, like break it down into a series of steps and kind of walk the LMM through exactly what to do, and you'll get better results. And then refinement is basically a form of priming, but we're actually giving it the security vulnerabilities to avoid. So it requires a little bit more security knowledge than some of these other ones, but can be very, very effective. Again, if you want to get all this information, there's a link here. You can also connect with me afterwards, but it'll give you a bunch of different examples of these different styles of prompts. So easy way to try a few, learn, and see what you can do. Would love to kind of hear your experiments. If there's any you guys end up trying and liking, it'd be great to hear about those too. So feel free to reach out. I'll pause here for a moment. Any questions so far? Not yet. Okay. Yeah. Yeah, so the question was, what is the biggest issue with vibe coding? Doesn't work is probably number one. So I'm going to show you the app here in a little bit. If I were to try to run it, I'd almost guarantee you it will fail and not work. The second after that, though, is insecure code. And that is a few different, I've been talking a lot about first-party code, but we'll talk a little bit about it more here in a minute. But actually, dependencies is actually a huge one. Without any tooling, we have a study we're releasing on this pretty soon, but only 20% of dependencies that AI pulls in are safe. So they either are hallucinated or have dependencies of that other 80% roughly. And I think that's an underappreciated challenge because we tend to think of AI as writing the code, not just what it's pulling into your application. It's kind of a unique one, yeah. Yeah. All right, so if you've ever tried to roll out security standards in your organization, you probably know how hard it is to get developers to actually learn and consistently implement them, right? I'm not very good either because I'm busy, I have things to do, and so it's really easy to forget to do something. And so the next step up we want to do is actually implementing rules in the organization. And so The nice thing with AI tools is you can actually build rules directly into the environment. You can do that through what's called a rules file. I'll show you an example here in a minute. There's also something called an ignore rule. I would not recommend relying on that in our experience. Your results vary depending on the model that you're using. But what rules allow you to do is actually encode your security standards or your code quality standards into the environment where the coding is happening. To show you an example here, in our organization at Endor Labs, just as an example, we're very strict about how you build your application. And so, for example, you have to use a specific library anytime you're handling input. So in this case, this is a bit of a made-up example. This is an our exact one, but we're actually writing a rule that's telling that the agent in Cursor to always use input sanitization and using a particular function and library to do that. But I would say with these rules, you want to make sure that really are targeted and unique to either your organization or the application. You don't want to go the route of, and I saw an example of this week from Cisco, where they basically dumped all the CWEs into a rules file and told you to inject that into Cursor. It's a nice idea, but it does not work. The fascinating thing about LMMs is they have, at least right now, maybe this will change, but they have a memory problem. They remember the first thing you told them and the last thing you told them, but they're really hazy on what you asked them to do in the middle. And so if you give them too much context at once, they tend to go off the rails in different directions. And so again, when you're giving them rules, it needs to be really tailored to your organization. Yeah. Lesson 3. All right, so we've given, we're doing some prompting. We've given some guidance that is kind of standard in the organization. The last thing I want to talk about is real-time security signal. And this is my artistically designed bread getting moldy, just in case anybody's having trouble interpreting that diagram. The reason I show that, though, is I think we kind of forget that these models can get moldy themselves. By the time most foundational models come out, they are anywhere from 3 to 6 months old. That means their data is 3 to 6 months old. And by the end of their life, they're often about a year out of date. And we did some experiments. We actually found that, especially with dependencies, this is a huge problem, right? Because they are biased to move quickly, they go to what's the most recent thing in their memory, which tends to be, again, a dependency version that is a year old. We have lots of graphs. I'm sure you've all seen them with like CVE growth, like 400% year over year or last 10 years. Point is, a lot of CVEs come out, and then that means you're actually pulling these into your application. We'll talk a little bit more about MCP. I'm sure you guys are pretty familiar with it, but what it allows you to do is actually inject that up-to-date security context. And so that can happen either through just strict data or also scanning to actually verify whether or not these are correct and secure. And then with MCP, and I'll show this an example here in a minute, you can actually guide the LMM to fix these issues at the source, so you're not having to go back and fix them later in review. And yeah, here's just an example again from our experiments. This was with ChatGPT 4. We were doing this, this was over this summer actually. And so we pulled in 2 really old dependencies. I believe Fast API actually had a vulnerability in it. And again, it's because ChatGPT's cutoff was about a year in the past, right? So again, it was pulling those old dependencies in. I also want to add, we did some research here recently, which we'll be putting out. So it's not just the pulling in, it's also even when you give these models tools, so not MCP, but like things like system prompts or things, internet access to go check the latest dependency. Even then, it's only about 30 to 40% of the dependencies they pull in are actually safe. Like, even when they have tools, they just bias to be fast and kind of miss these issues. How many people know what an MCP server is already before I spend too much time? Okay, anybody not know what it is? I need a quick. Okay, it stands for Model Context Protocol. What it is, it's a standard way to give an LMM access to tools, data, or customized prompts. So it's a way for an LMM to access other systems. So for example, if I am working in Cursor, I could access Endor Labs to scan my code, check for vulnerabilities, that kind of stuff. So I think of it as just a really fancy API, but it's actually a mini server that has to run to give the LLM access to your content. I think we all know, so generally I think understanding that like kind of API access is pretty straightforward. The other part of an MCP server, though, are the rules that you can ship with it. And so this is an example of the rule we ship with the Ender Labs MCP server. The reason I want to call it out, though, is it's another good example of rule writing. In this case, we are actually telling the LMM every time it adds a dependency to your manifest to actually secure, or to review it for vulnerabilities and then upgrade it if needed. So again, it's a way to help these tools write more secure code by default rather than having to wait until something hits CI or later in production. Okay, now we're going to divide code and app together and see some of this stuff in action. Okay, so this is Cursor. Before we start vibe coding, I just want to show you a few places where things work. So there's this .cursor directory. Yeah. You're not sharing. Oh, I'm not. Thank you. I know there's a hotkey, and I don't remember the hotkey. Break is over. All right, so in Cursor, you have what's called a .cursor directory. This is where your rules live and your MCP server. So here's an example of the MCP server I'll be using tonight, which is Ender Labs. Not very much, just a little bit of JSON telling you basically what its name is, the command that it's using, and the arguments to use. So very simple, very straightforward, easy to add. And then I wanted to show you an example of those rules. So again, we'll go to SEA. It's a little more interesting. So this is the full SEA rule that ships with the server, right? So I think the key things here start with the important. We're not going to let it proceed unless we, anytime it modifies a manifest file, and we have that whole list of files later in the rules. Anytime it modifies that, we're going to make it scan it to make sure that it's using safe dependencies. Again, the rest of this is just rules. Like when it finds a vulnerability, it has to either go to a safe version or replace with a non-vulnerable alternative. Again, we're automatically detect or fix any errors. Anyway, so that's how that's going to work. And today we're going to build a to-do list app. We use some JavaScript and some Python. It's just going to be a to-do list app. So pretty simple. And we're not giving it any security guidance this time, so that way we can kind of see how some of this works in practice. I've also done something you shouldn't do. I'm going to let this fully run on its own. I am not going to be stopping it. So we'll see what it does. So it's going to start, breaks down the task itself. That's based on the rules in Cursor. And it's already updating requirements.txt. So it can start building its application. And interestingly, it skipped the check. So what happens with LLM sometimes? Let's see if I get to it again. So now we're working on the front end. So it's again pulling in a bunch of JavaScript React. This is when we get a bunch of dependency load all of a sudden. Thinking for a second. While it's working, yeah. I'm just using 3.5 because I know it works in this demo. I haven't tested the newest one yet. The
demo gods.
Yeah, and even then, it's still unpredictable. So yeah, like newer models tend to perform a little bit better. I just haven't tested to see if it will actually trigger the right things at the right times. Right, so it's built it. We have a front end and back end. Now, all right, so in this case, decided to do the security scan at the end rather than as it goes. So in this case, because we've made those modifications, it's kicking off the scan. It's looking at what it just changed. And it should come back and see that it's got a vulnerability. If not, we'll go inspect and see what it actually did. It takes a while, I guess. All right. All right, yeah, so I did find a vulnerability. So it's actually gone ahead and updated the requirements.txt file at this point for us. We've also had some SAST issues, so it's also making some modifications to cores, and now it's going to verify its changes to make sure it's fixed everything. And at this point, while it's doing that, we can kind of poke in and see what it actually built. So we have a front end. Let's see. Not too bad in terms of direct dependencies, right? We only have, I don't know, 6 or 7. And we haven't installed everything yet. We have our public front end, few components, and then this is where I was making the changes, right? It had this Flask cores was outdated and had a vulnerability, so it upgraded it for us as it worked. And it's happy, it says it's fixed everything. So I guess good job, Cursor, you did better today than you've done in the past. Sometimes we run this, we also find that Axios, another dependency that we use in React, tends to be vulnerable. In this case, it's just one. But yeah, all of that took, I don't know, a couple minutes once I got it working, and now we have what might be a working app. I'm not going to try it because I'm pretty sure it's not going to work. But, try it? Okay. Yeah, so let's tell it, run it for me. Okay. We have to start our backend and start our front end. Okay. I don't have a configured working developer environment, so we're going to stop here because I'm not a developer. Oh, it's still doing something. I guess it solved that. Good job. That's scary. I didn't used to be able to know how to do that. So just modified my local machine to add pip3. That's a little scary, actually. And now we're running our server. Oh, we're installing all those dependencies. That might take a second. I have several hundred React dependencies. Okay. All right, let's go. Send it to prod. Let's see what happens. Yes. I will. Oh, all right. Compiled with problems. Well, if I was doing this for real, I'd be spending the next 5 hours trying to debug what went wrong. But you lived a broken app in about 5 minutes. That's not bad. Usually takes me longer to break something. So, all right. So that is vibe coding. That is what happens. Where am I? All right, so just to kind of recap, things I didn't do in that session, I did not use a secure prompt. So something I could have done is actually to write secure code. We might have done a little bit better. We did have some security standards, but they're really just our generic MCP rules. We didn't have anything specific like sanitize whatever input I'm putting into the application. And then we at least did add some security signals. So even if the application didn't work, we at least made sure the dependencies and code passed our SAST and SCA scans. So some basic steps. Obviously, there's a lot more you could do, but this is kind of, I think, an easy place to start. And appreciate the time tonight. So any questions? You can also connect with me on LinkedIn. I'll share that deck, or if any of those studies I mentioned are interesting to you, and I'll also share those links. But yeah. Yeah, pricing for labs is per developer. We sell as SCA is the core, and then you can add on SAST. And so it kind of depends on how many developers you have. Yeah. Other questions? Yeah.
What's the state of life coding currently in an ideal situation where you have a group of developers and you want to leverage AI and these tools, but you don't want to break anything. So for example, if this was a small part of a larger application and you wanted to submit it to the rest of the
To the team.
repository, how confident do you feel about it? I mean, after you fix the
Yeah.
different.
A couple things there. So the kind of question is like state of vibe coding today, but particularly in an organization. So, obviously most developers aren't going to do what I just did, where I just kind of vibe coded something purely from the start. That said, there are more mature ways of doing this than I showed you. So if I was only building a front-end application, for example, I could use Lovable. We actually did a test with Lovable. No real security issues, right? Because they built the platform to be really narrowly focused on delivering a website and building that website in a way that's secure. So that's kind of one sort of no-code path. On the other path, there are things like, I think what we were seeing with like SourceGraph AMP and others that are trying to build a little bit more mature processes around this. But at the end of the day, like I, as a developer, I'm going to check this in. I think this is your question, into a pull request where I'm going to have to go to review. And code review is actually, I would say, the biggest blocker in productivity. So, I think a lot of organizations are adopting these tools wanting to see more productivity. But if you even ask Google how productive they are, they say it's like 10%. There's also studies that kind of validate that, like most developers at the professional level building with this only see about a 10% boost in productivity. Unless you're junior or like me, and then you get about a 40% boost in productivity. But the question is, how good is that productivity? And so the gap is code review. And I think that's where we see tools like CodeRabbit, but also like Ender Labs. We have something kind of similar on code review, which is actually looking for those design flaws I talked about. So not just is the app functioning, is it passing a SAS or SEA scan, but have you modified something? And that's where things get interesting, because that's where you find those logic things that kind of slipped past the code review, right? Because humans are great, but we don't catch everything. And I think to get like a 95% confidence level, I think the stats are you need like 12 to 15 engineers to look at it, which is not ever going to happen, right? Nobody has that much time to review code. And so those are the kind of gaps you have to kind of close in an environment. But yeah, I hope that answers your question. Other questions, comments? Anybody go wipe an app tonight? All right. If not, I appreciate the time. Thank you so much for talking, letting me speak with you all today. And yeah, happy to stick around and talk some more one-on-one. Thank you.
Everybody is waiting for
Food.